Welcome to Backlight, where we'll be taking you behind the scenes of our investigations at Lighthouse Reports. Every month, we will be interviewing a lead contributor behind one of our recent investigations for practical insights into how these are conducted. My name is Beatriz Ramalho da Silva, and I'm an investigations reporter at Lighthouse. Today, I'm joined by my colleague, Eva Constantaras, who is our data editor at Lighthouse Reports. She led the Suspicious Machines investigation, which was published in a 4-part series with Wired magazine. Our team spent a year and a half working on the story. They obtained the code for a complex artificial intelligence algorithm designed to predict benefits fraud in the Dutch city of Rotterdam. And then they conducted an experiment in order to audit this algorithm. The investigation revealed how the deployment of this predictive algorithm led to discrimination and wide-scale surveillance with a devastating impact on the lives of those who found themselves being wrongly investigated for fraud. Hey Eva, this is the first time that journalists have been able to conduct an in-depth assessment of one of these machine learning predictive systems. Can you talk us through how you did this and firstly how you worked to obtain what you call the holy trinity of algorithmic accountability and what this is?
Hi, Beatrice. It's great speaking with you. And this has been a long learning process for us in everything required to really do solid algorithm accountability journalism. If you think about it, in order to do a really robust assessment of an algorithm, you need a few things. You need the input. So you need basically what is fed into the system. So that's the data that goes into the system. You need to understand a bit about how the system was built. So that's what we refer to as the code that the system was built on. You need access to the system itself. So basically what they finally decided to use, the model that they decided to use after testing out a couple of different models. And then once you have those three things, so you have the input data that's fed into the system, you have a pretty clear idea of how the system works based on the source code, and then you have the final model file of the system itself, you can actually generate your own scores. So the first thing we actually got, among the first things, was the source code, and we got this through a FOIA process. But with this alone, there's not a whole lot you can do. Like some things can kind of raise red flags, some things can seem kind of off, but we can't really interrogate the system without more information. So what we got next, which was kind of a surprise, was the final model file. And this is basically the code that you run to get people's actual scores. And the way we got that was initially through FOIA. We requested the final model file through FOIA. It went to the courts. We had a court hearing, and then kind of on the sidelines of that court hearing, we negotiated with the city, and they basically said, yes, you can have the final model file, but it kind of as long as you run the results that you get by us before you publish, which we would have done anyway. There was an interesting little tidbit that we did hear them. They didn't realize that some of our group spoke Dutch. They were talking kind of by the water cooler, and they basically said, we'll give them the final model file, but this is going to make us look really bad. So we were pretty excited for that victory. That excitement didn't last long because we realized that although we had the final model file, we didn't actually have any data to run through it to get scores. And the problem was there's 315 different pieces of information about each person that gets run through this system. And so what we wanted to do was synthesize data, so basically make up people and run them through and see what their score was. But it's hard to make up realistic combinations of 315 different variables. So we were a little bit stuck, and what we decided to do was we had requested the original training data, so that was basically the real data that they fed through the machine to generate their model, and they had said no based on GDPR, which is, individual data privacy concerns. So what we asked for was basically the distribution of each of the variable values. So if you think about it, we wanted to know, for example, okay, well, how old was everybody in the data set? Like, how many people were between the age of 20 and 25? How many people were between the age of 30 and at 35, and so forth? So at least give us a histogram, a chart that shows us how the data is distributed. So in that case, at least we could combine variables that make more or less realistic people. And actually, they did agree to that. So they sent us these histogram charts showing us the distribution of data across all of the variables. And what we realized is they sent us these charts as HTML files. And when we looked at the code used to generate the charts, it actually included all of the data to generate the charts. So basically, they'd accidentally sent us not just the charts, but all of the data behind the charts, which was all of the training data of all of the people behind the 12,000 rows of data. And Rotterdam did, in fact, confirm that they had accidentally sent us the entire training data set. So this was the last really important thing. This is the last element of the Holy Trinity to be able to do a full experiment.
So, after all of this process, to prove that the risk scoring model was discriminating against specific groups, you guys carried out an experiment. Can you tell us a little bit more about that?
We carried out two experiments. The first one was basically we looked at who would probably be flagged for an investigation. So the way the Rotterdam algorithm works is everyone's assigned a score between 0 and 1, and the top X number are referred for an investigation. So it usually ends up about being the top 10% of people. So one thing we did was look at, okay, how many people, what percentage of people of these protected classes or these sensitive groups fell above that 10% threshold. So for example, if half of the welfare recipients in a data set are women, then you would think that only half of that should also be reflected in the 10% cutoff. So only half of the high risk people should be women. And what we found is this wasn't always the case. So women were overrepresented in the high risk group. People with poor Dutch language skills were represented in the high risk group. But what we couldn't tell from this was whether it was their gender or their language skills that was really pushing up their score, or if it was something else correlated with gender or with language skills. So we basically wanted to control for all of the other variables in the data set and figure out, okay, but what's really driving up the score? And we really struggled with how to do this. And what we finally settled on was we took the entire training data set and we made two copies. And in one copy, we just switched one variable to one value, and for the other copy suite, we switched the other variable to the opposite value. So for example, we switched everyone to male in one set, and then we switched everyone to female in the other set. And then we looked at how did their scores compare above and below that 10% threshold. So what we saw in that example, for example, when we changed everyone to male, males were underrepresented. Most of their scores fell disproportionately below the 10% cutoff. And women, on the other hand, fell disproportionately above the 10% cutoff. And again, the only thing we changed was gender. So then we could attribute gender is the root cause of why they were being flagged at a higher rate for investigation.
Eva, lastly, I wanted to ask you, why do you feel this story is important now? And what are the wider implications of these findings?
So I think one of the lessons we learned when doing this is there's very few people involved in these systems that actually understand how they work and can question the system. So it's not just a matter of, in our case, we looked at single mothers. It's not just a matter of these single mothers being able to ask for their data, to be able to ask for their score. It's also that their caseworkers don't really understand why they were flagged as high risk. The lawyers might not really understand why they're flagged for high risk, and the judges might not understand. So there's nobody really in this system who understands how the score is derived. And what we found when we did this experiment is basically it's really not straightforward because, for example, everyone's score is affected slightly differently depending on a combination of variables. So what I talked about with the experiment is on average women were overrepresented, but each person was judged uniquely by this algorithm. So, if a woman who doesn't speak Dutch from a certain neighborhood, gender affects her score differently than, a fluent Dutch speaker who's much older, who lives in a different neighborhood. Her gender brings her score. It might bring it up, but not as much as that single mother from without Dutch language skills. So this kind of non-linearity about how the system is biased, I think is at the root of why it's so hard to push for accountability for these systems. What we think, even with all of this transparency and even getting this unprecedented access, it was still quite difficult to prove in a way that people can understand that these systems are discriminatory and the bias is built into the system. And I think a point that we want people to understand is no matter how much you tweak the model, how much you revise the training data, the messy reality of people's lives and why illegal acts are being committed is probably something that can't be captured by an algorithm. So even though there are 315 variables going into it, there isn't this magic secret pattern that's going to actually be able to predict who among these people are committing fraud.
Thank you so much, Eva.
Thank you.
You can read more about our investigation with Wired and the methodology behind the story on our Lighthouse Reports website.